Welcome to the class, my dear students. In today's lecture, I am going to give the Poisson distribution. Among the discrete probability distributions, we have the very important distributions in discrete probability distributions are one is binomial, the other is Poisson. In my previous lectures, I have explained what is meant by the binomial. When there are two outcomes, that is a binomial distribution. Now we are going to discuss about the Poisson distribution, and then we will be solving some of the problems in this lecture. And to be alert, where do we use binomial and where do we use Poisson distribution is very important. So let us pay attention in finding out the difference between the Poisson and the binomial distributions. Now, coming to this distribution, first of all, when you see that in the discrete probability distributions, when the sample size is getting large, the probability of the success becomes small. Why this happens, this I will explain in the definition, and then you will understand very clearly. And then the definition of the Poisson distribution is being defined as P of x is equal to x is e raised to minus lambda times of lambda to the power of x by x factorial, where x is 0, 1, 2 and so on. What do you mean by lambda? Lambda is the mean. Mean is given by n into p. What is n here? N is the number of trials and p is the probability of the success. So in this Poisson distribution, the mean and variance are the same. That means lambda is mean, lambda is the variance, and the standard deviation is square root of the variance is the same. Yes, now I'll explain about this point here. When you say that lambda is equal to n into p, so what is the success here? When I ask you what is the probability of the success means, it will be lambda by n. So now when n becomes larger, that means let us say lambda is some value, lambda by some bigger number it is, suppose. Any number which is bigger number, say n is 100, let us say. Then definitely the value, when n is bigger, the probability p is getting smaller and smaller. Let us consider, for example, lambda is equal to 1. Okay. Now, when 1 by 100 if you take, then it is 0.01. The probability of the success is very less, right? 0.01. Suppose let us take our n is 1000. Then it becomes still very less, that is 0.001. So what is happening here? The p, the value of the success, getting smaller and smaller as our n getting larger and larger. So the Poisson distribution explains that whenever the sample size, whenever the number of trials is more, then and the success will become less. And this Poisson distribution is applicable whenever this number of trials is a bigger number. Like let me say n is greater than 50. Whenever you can make a note of this. N is greater than 50. Immediately you can see that the distribution which you have to use here is the Poisson distribution. While doing the problems, I'll make you more clear about this Poisson distributions. And here the mean is given by lambda. Variance is also equal. Both of them are equal in this Poisson distribution. Let us now make a difference between binomial and Poisson so that it will be easy for you to memorize. Let us say binomial and Poisson distributions we have. So let us write down clearly what are those. First of all, n is the number of trials is small and the number of trials n is large. And now when you take this, what is the mean here in the binomial distribution? The mean is given by n into p in the binomial. And what is in the Poisson? The mean is given by also np, that is equal to lambda. And what is the variance in the binomial distribution? np into q. Whereas the variance in the Poisson distribution is the same, that is lambda itself. So which distribution, the mean and variance are the same, means it is Poisson distribution. Okay. And what is the probability distribution function for in the binomial distribution is ncx, p to the power of x and q to the power of n minus x. And what is this now? P of x is equal to x is given by, since the n is very large, we cannot take like this. Yes, so it is e raised to minus lambda into lambda to the power of x over x factorial, e power minus lambda into lambda power x time over x factorial, where x is from 0, 1, 2, 3 and so on. So these are the major differences whenever, and of course you can say that as n is large, the success p is small. Comparatively very small value is p. Okay. So depending upon the problem, accordingly you have to understand which distribution you have to use in this discrete binomial, in the discrete probability distribution functions. Okay. Let us now come to the question. A manager, let us read. A manager of a power generating company believes that 2% of the generator's failures occur in winter and 200 failures are expected in a year. So find none of them will occur in winter. So the question is this. So let us first of all understand how many are there now. That is 200. That is a bigger number. As soon as you say that is a bigger number, immediately you can say that. Again, here also you can say both the outcomes are 2 only here, right? But we are using the number of trials, that is what bigger number, that is more than 50. So let us now consider that n is equal to, here what is it, 200. N is equal to 200. And what is x here first of all? What is x here? Now the question asked is what? The failures, the number of the generators failures occur. That means what? X is nothing but the number of failures. So our favorable event is number of failures. So P is what? Probability of failures. Probability of failures is your P. And what is given that P is what? 2% of the generators failures. So 2% means it is 0.02. Now what is Q? Now you need not find out Q also, because what is the formula for Poisson? Whenever you see that it is bigger number and the number of failures or something like this you have seen, you can understand that it is Poisson distribution. And now coming to the point, what is first of all asked you is none of them will occur in winter. For finding out that, first of all, let us say the first one, asked question is P of x is equal to 0. What is the probability distribution function in the Poisson distribution? For the Poisson distribution is what? P of x equal to x is given by e power minus lambda into lambda power x over x factorial. So this is what the problem. So now what is P of x is equal to 0? That means what? It is, you have to find out what, this is the first question asked. Now what is lambda? Lambda is given by n into P. That is what the mean. Mean is given by n into P. N is what? 200 and P is what? 2%, means 2 by 100. That is 0.02 anyhow it is written. So it is 2 2s are 4. 4 is your lambda. My mean is lambda. So now we have to find out what is P of x is equal to 0. That is e raised to minus lambda, lambda power x over x factorial. Here what is your lambda is 4 and x is 0. So that is given by e power minus 4 times 4 to the power of 0 by 0 factorial. So that gives you what? E raised to minus 4. So what is the value of e power minus 4 is 0.0183. You can use your calculator to get the solution for this. Now let us come to the second question. What is that? Exactly 2 of them will occur in winter. What do you mean by exactly 2? P of x is equal to 2 is given by e raised to minus 4, 4 to the power of 2 over 2 factorial. So what is this? It is 0.1465. So this is what the way of doing the problems using the binomial distribution. Let us now go to the next problem. If a random variable x follows Poisson distribution such that p of x equal to 1 equal to twice of p of x equal to 2. So find the mean variance, mean variance, I cannot change it actually, mean variance, and second one p x greater than or equal to 1 and p of x equal to 3. So this is what we have to do now in this question. So what is given? It is already given that it is a Poisson distribution. Now, if it is given, not an issue. So now, what is P of x is equal to x? First of all, the formula in Poisson distribution, e raised to minus lambda, lambda power x over x factorial. Now, what is given? P of x equal to 1 is twice of P of x is equal to 2. So, what is P of x equal to 1? E raised to minus lambda, lambda power 1, which is lambda, by x factorial, that means 1 factorial, is given by 2 times of e raised to minus lambda, lambda power 2, now x is 2, over 2 factorial. 2 factorial is what? And I hope you know what is meant by 2 factorial, 3 factorial and so on. So you can always find out, your calculator is also there. So the factorial is the number of times it is possible. So now the value of this is what? E raised to minus lambda times of lambda square. 2 gets a cancel. So it is e raised to minus lambda into lambda is this. E raised to minus lambda times of lambda is e raised to minus lambda times of lambda square. So what it gives you? Lambda is equal to lambda square. It implies lambda is equal to 1. So we can say actually lambda equal to 0 comma 1, but you cannot say mean is 0 or something. So we say that therefore that lambda is equal to 1. Therefore what is the mean? Mean and variance, both of them are equal to 1. Okay. And now next question is p of x greater than or equal to 1. So the second question is p of x greater than or equal to 1. So to get p of x greater than or equal to 1, actually you have to find out for greater than or equal to 1 means up to 2, 3, 4 and so on. But it cannot be done, right? So it is easy to find out as p of x is less than 1 by subtracting from 1. What is p of x less than 1? Is nothing but x equal to 0. So let us do this. That is 1 minus of e raised to minus lambda into lambda power x means 0 over 0 factorial. So what is this? 1 minus e raised to minus lambda means minus 1. Lambda power 0 is 1, 0 factorial is also 1. So it is 1 minus e power minus 1. And what is this value? This value is what? E power minus lambda. That is 1 minus e power minus 1. So that value gives you